A few years ago, a customer brought in his truck complaining it felt sluggish, like it was dragging an invisible anchor everywhere it went. He had already spent over $800 at another shop, replacing spark plugs, cleaning injectors, even swapping out the mass airflow sensor. Nothing worked. I popped the hood, ran my hand along a simple rubber hose, and found the culprit in less than 30 seconds. A tiny crack, barely visible to the naked eye, was bleeding vacuum pressure like an open wound. I fixed it with a $3 part and 10 minutes of work. The truck roared back to life, like it had gained 50 horsepower overnight. The look on his face was priceless, but also heartbreaking, because he had wasted hundreds of dollars chasing a ghost when the real problem was hiding in plain sight the entire time. That invisible thief is called a vacuum leak, and it is one of the most common, most misdiagnosed, and most overlooked problems in modern engines. It does not make loud noises. It does not leave puddles under your car. It does not trigger dramatic warning lights, at least not at first. But what it does is slowly strangle your engine's performance, waste your fuel, and send you on wild goose chases that empty your wallet. Today, I am going to show you exactly how to find this hidden leak in under 2 minutes and fix it yourself without spending more than a few dollars. And trust me, once you understand how this works, you will wonder why no mechanic ever bothered to explain it to you before. To understand why vacuum leaks are so devastating, you first need to understand what vacuum actually does in your engine. When the engine runs, the pistons move down and create suction, pulling air through the intake manifold. That suction, that negative pressure, is what we call engine vacuum. It is not just a byproduct of combustion, it is used to operate dozens of systems in your car. Brake boosters rely on it. Emission control valves depend on it. The PCV system needs it. Even climate control flaps may use vacuum to direct airflow. But most importantly, the engine computer uses vacuum readings to calculate exactly how much fuel to inject. When that vacuum is compromised, everything falls apart like dominoes. Here is what happens when air sneaks in where it should not. Your engine expects a precise mixture of air and fuel, typically around 14.7 parts air to 1 part fuel. The engine computer monitors airflow through sensors and adjusts fuel injection accordingly. But when unmetered air enters through a crack or loose connection, the computer does not know about it. It still injects fuel based on what it thinks is coming in, but the actual mixture becomes too lean. Too much air, not enough fuel. The engine compensates by pulling timing, reducing power, and running rough. You feel it as hesitation, stumbling, poor acceleration, and that frustrating sensation that your car just does not have the punch it used to. The tricky part is that vacuum leaks often do not throw obvious codes right away. Your check engine light might stay off for weeks or even months, while the leak slowly gets worse. When a code finally does appear, it is usually something vague like system too lean or random misfire detected, which sends most people and even some mechanics down the wrong path. They start replacing oxygen sensors, fuel injectors, catalytic converters, all expensive parts that were never the problem to begin with. Meanwhile, a $2 piece of cracked rubber sits there laughing at everyone. The most common culprits are easier to find than you'd think once you know where to look. Start with the intake manifold gasket, especially on engines with plastic intake manifolds that expand and contract with heat cycles. Over time, those gaskets dry out and shrink, creating gaps where air rushes in. Next, check every vacuum hose connected to the intake. These rubber lines become brittle with age and heat exposure. They crack at the connection points first, right where they slip onto metal or plastic nipples. A hose might look perfectly fine from the outside, but have a hairline split right at the end that only opens up when the engine is warm and vibrating. The positive crankcase ventilation valve and its associated hoses are a common offender. This valve is supposed to recirculate crankcase gases back into the intake, but when a hose cracks or the valve sticks open, it creates an unmetered air path that throws off the entire system. Small leaks upset the air-fuel ratio, and that can cause hesitation, a rough idle, and vague trouble codes. Check hoses for cracks and the valve for sticking, because small fixes can often restore performance. Leak. The brake booster hose is another sneaky issue. It is a large diameter hose that runs from the intake to the brake booster, and because it is tucked behind the engine in most cars, people rarely inspect it. A leak here not only affects engine performance, it can also make your brake pedal feel hard and unresponsive because the booster loses the vacuum it needs to multiply your pedal pressure. Vacuum. Throttle body gaskets fail more often than most people realize, especially on high-mileage vehicles. The gasket sits between the throttle body and the intake manifold, and even a tiny gap there introduces a significant amount of unmetered air. Some engines have plastic intake runners that actually crack over time, creating internal leaks that are nearly impossible to spot visually. I have seen intake manifolds on certain German cars that develop cracks inside the plenum where you would never think to look without removing the entire assembly. Now here is the part everyone wants to know. How do you actually find these leaks without expensive diagnostic equipment? The simplest method that works 90% of the time requires nothing more than a can of carburetor cleaner or starting fluid and about 2 minutes of your time. With the engine running and warmed up to operating temperature, carefully spray short bursts of the cleaner around every vacuum connection, gasket surface, and hose you can reach. Work methodically, one area at a time. When the spray hits a leak, the engine will suddenly change its idle speed, usually revving up momentarily as it burns the flammable cleaner that got sucked in through the gap. That change in engine speed tells you exactly where the leak is hiding. A word of caution. Carburetor cleaner is flammable, and you are spraying it near a hot engine. Work in a well-ventilated area. Keep the can away from exhaust manifolds and spark plug wires, and do not go crazy with long, continuous sprays. Short, controlled bursts are all you need. Some mechanics prefer using propane from an unlit torch for this test because it is slightly safer and gives a more obvious change in engine speed, but carburetor cleaner works perfectly fine for most situations. Another method that costs absolutely nothing is the visual and tactile inspection. With the engine off and cool, squeeze every vacuum hose you can find. Healthy rubber feels pliable and returns to shape. Brittle hoses feel hard. They may crack when bent or show visible deterioration at the ends. Pull gently on each connection to make sure hoses are fully seated on their fittings. A hose that slides off easily was probably already leaking. Look for oil residue or discoloration around gasket surfaces, which often indicates air has been passing through. Check the intake manifold bolts to make sure none have backed out or broken, creating gaps in the gasket seal. If you want to get slightly more sophisticated, you can perform a smoke test using an inexpensive smoke machine that feeds theatrical fog into the intake system while the engine is off. The smoke will escape from any leak point, making cracks and gaps visually obvious even in hard-to-reach areas. Professional shops use more expensive smoke machines, but you can buy basic units online for around $50, and they work well enough for occasional home use. Some resourceful mechanics even build their own from a paint can, an aquarium pump, and some mineral oil, but I recommend buying the proper tool if you plan to use it more than once. Once you have located the leak, The fix is usually straightforward. Most vacuum hoses are inexpensive and easy to replace. Buy the correct diameter hose from any auto parts store, cut it to length, and push it firmly onto the fittings. For gasket leaks, you'll need to remove the affected component, clean both surfaces thoroughly, and install a new gasket with the proper torque sequence. Intake manifold gaskets on some engines can be a bigger job that takes a few hours, but the parts themselves rarely cost more than $20 or $30. Compared to the hundreds you might spend chasing phantom problems, it's nothing. What surprises most people is how dramatically their car improves after fixing a vacuum leak they did not even know existed. Idle becomes smooth. Throttle response sharpens. Fuel economy improves, sometimes by 2 or 3 miles per gallon. That hesitation off the line disappears. The engine feels eager again, willing to rev, happy to work. It is like removing a weight you did not know you were carrying. And the satisfaction of solving the problem yourself with a few dollars and a few minutes of work is something no shop visit can replicate. The lesson here goes beyond vacuum leaks. It is about understanding that the most expensive problems are not always caused by the most expensive parts. Modern engines are complex, but they still rely on basic principles that anyone can learn. Air goes in, fuel mixes, spark ignites, power comes out. When something disrupts that sequence, the answer is often simpler than the diagnostic computer suggests. Mechanics who have been doing this for decades know to check the simple things first, but shops that charge by the hour do not always have incentive to find the cheap solution. That is why knowing these fundamentals yourself is worth more than any extended warranty. So the next time your car feels tired, sluggish, or just not quite right, do not immediately assume the worst. Grab a can of carburetor cleaner, spend 2 minutes methodically testing your vacuum system, and you might just find that invisible thief who has been stealing your engine's power all along. Fix that crack, replace that brittle hose, tighten that loose connection, and your engine will thank you with performance you forgot it had. It is one of those rare situations where a tiny investment of time and money returns massive dividends, and now you know exactly how to do it yourself.